Morning session we are started to discuss about the lasers, right? Two students are present. Okay, shall I start the class? Shall I?
Yes, sir.
Yeah. Okay. What we discussed in the morning session? What we discussed in the morning session? We started lasers, right? We started to discuss about the lasers. In that we discussed the basics involved in the lasing action, right? Like mechanism involved in the laser. That is stimulated emission, stimulated absorption, and spontaneous emission. The three topics we discussed in the morning session, including that, where we started to discuss about the basic definitions like population, population inversion, and metastable state. So coming to the population again, the number of atoms in a particular energy state is called as a population. Population. The general occupation of population according to the formula Ni equals to N naught into exponential of N2 by N1 is the formula actually. So according to that formula, population is the number of atoms are occupied in various energy states. So coming to the population, general occupation of population is the lower energy state having more number of atoms than the higher energy state. That is the usual occupation of population. If N1 number of atoms in the ground state and N2 is number of atoms in the first excited state and N3 is the second excited state. The usual occupation population is N1 is always greater than to the N2 and greater than to the N3 and so on. So when we achieved N2 greater than N1, N2 greater than N1 or N3 greater than N2 is called as population inversion. Nothing but the number of atoms in the excited state is greater than the lower energy state is called as population inversion. When we are taking two energy levels, usual occupation of population I showed in the morning session. At the same time, population inversion also I showed in the morning session by taking two energy levels. If we represent like this is the usual occupation of population because of E2 having less number of atoms than the E1, means ground state having more number of atoms. So when we achieve like this, means N2 having more number of atoms than the N1 or E1, is called as population inversion. Same energy levels, I am taken E2 and E1. Here this post diagram represents usual occupation of population and second one represents population inversion. So here this is the N1 and this is the N2. Again here N1 here and N2. So here N1 is less than N1 is greater than N2. Here N1 is less than the N2 is called as population inversion. Right? To achieve this population inversion, we need to send the atoms from ground state to the higher energy state using the pumping mechanisms. Pumping mechanism, nothing but to send the atoms from lower energy state to higher energy state, you are using pumping mechanisms. So different type of laser having, every laser having different type of pumping mechanism. For example, we have a type of laser like ruby laser. So in the ruby laser, for example, ruby laser is one of the laser. So in the ruby laser, xenon flash tube is acted as a pumping mechanism. So using the flash tube, we are sending the neon particles or chromium particles from ground state to the higher energy state in the ruby laser. That's why we are called as a pumping mechanism. Xenon flash tube is a pumping mechanism in the ruby laser. So first thing is population inversion. To achieve the laser, population inversion is getting the population inversion between the existing energy levels in every type of laser is compulsory. To achieve this population inversion, we are using pumping mechanisms, pumping sources. So we have different type of pumping mechanisms like uh, uh, atom inelastic collision, atom inelastic collision. Types of pumping mechanisms we have, I will show you in the PPT. Right. Again, I am coming from the first slide. This is the one stimulated absorption, and this is a spontaneous emission, and this is stimulated emission. These topics already discussed we are in the morning session. Coming to the population and population inversion. So population inversion can be achieved by number of ways. Some of them are optical pumping, which we used in the ruby laser, electrical recharge. That one is used in the um, helium neon laser, inelastic collision of atoms. We are using in semiconductor laser, chemical reaction, and direct conversion are the other type of pumping mechanisms. These are pumping mechanisms: optical pumping, electrical discharge, inelastic collision, chemical reaction, direct conversion are the some of the methods which we use as a pumping mechanisms in the lasers. For example is the optical pumping, one of the example which we used in the ruby laser. Okay, so these are some definitions about the lasers. One is population and population inversion. Second thing is metastable state and pumping mechanisms. These are four basic definitions. Try to remember all the definitions, including the absorption emission processes. Okay, now we will see what are the requirements for the lasers. What are the requirements for the laser? So one is the active medium. See, laser system. So laser system consisting of basic three parts. One is the active medium. Second thing is energy source, nothing but to establish the population inversion. We are using pumping mechanism. That is source of pumping is called as the energy source, and optical cavity to intense the to give a feedback. Okay, to give the feedback, we are using optical cavity or resonator. So in every type, usually in every type of laser, we are using two mirrors. For example, in the ruby crystal, the two ends of the ruby crystal are silver. One end is fully silver and one end is partially silver. From the partially silver end, we are getting the laser beam. But the two silver ends act as a optical resonator to give a feedback to the photons. Okay, so we are using that optical resonator. These are the main parts, three main parts available in the lasing system. One is the active medium, and second one is the energy source, and third one is the optical resonator. So in the active medium, total lasing action takes place within the active medium. So that in that active particles also present. We will discuss at the time of every type of lasers. Up to now, all of you remember basic three parts consisting in the lasing system or laser system. One is the active medium. In that active medium, total action takes place. So total lasing action takes place within the active medium. For example, in the ruby crystal, ruby laser, ruby crystal is acted as a active medium. In the helium, we have only two types of lasers in the types of lasers in our syllabus. One is the ruby crystal, ruby laser, and second one is the helium neon laser. Helium neon laser lo discharge tube, which is filled with the helium and neon, is acted as a active medium. So energy source. So energy source nothing but pumping mechanisms to send the particles or to send the atoms from ground state to the higher energy state in the process of achievement of population inversion. We are using these energy sources or pumping mechanisms. Xenon flash tube or optical pumping, that is called as the optical pumping, is used in ruby laser. At the same time, electrical discharge is used as a pumping mechanism in the helium neon laser. That are the examples for the pumping mechanism. After that, optical cavity or resonator. to give optical feedback up to sufficient intense that photons are released photons in the de-excitation process or get multiple reflections between the two mirrors. So to give the optical feedback, we are using this optical resonator. After sufficient intense, that laser that the energy are totally converting and converting it as a laser source, which is comes from the partially reflected mirror. These are the three main sections available in the laser system. This diagram clearly shows this is the active medium. 1 second. Where it is? This one is sorry. This is a laser medium. So cooling system to protect the operators. Where total lasing action they are conducting in the cooling system or cooling chamber. So these are the pumping mechanisms, and these two mirrors, these two are the called as a blue color. Two mirrors are acted as a optical resonator. The general construction of laser system. So laser medium, total lasing action takes place within the laser medium. To give the optical feedback means up to sufficient intense, the laser beam means photons are get multiple reflections between the two mirrors. After sufficient intense, the output laser comes from the partially reflected mirror. This total we are conducting in the cooling chamber, because while getting the laser, all the operators are very heated. There is a chance of damage of operators. That's why we are conducting total lasing action within the cooling system. So in the Ruby laser, for example, we are using liquid nitrogen or cooling water as a cooling system or coolant. So your pumping system is different types of pumping mechanisms depends on the type of laser. So for example, in the Ruby laser, xenon flash tube, already we discussed in the optical pumping, that is called as a optical pumping. Now coming to the characteristics of lasers, all of you try to note down the characteristics of lasers. Here 4 characteristics of we have already: monochromaticity, high degree of coherence, high directionality, and high brightness. So coming to the monochromaticity, we know. So every laser producing a single color means having more single wavelength. Single wavelength nothing but monochrome. It is called as a monochromaticity. See, in a laser radiation, all the photons emitted between the discrete energy level will have same wavelength. Means the laser beam already the photons are already having coherence. Coherence nothing but two waves are, when the two waves are within the phase, we call as coherent. That waves are coherent waves. So which we release in the de-excitation process or stimulate the emission of radiation, all the photons are within the phase. That's why they are highly coherent waves. So due to the coherent, all the waves are having same wavelength. So as a result, the radiation is monochromatic in nature. Due to stimulated characteristic of laser light, the laser light is more monochromatic than the conventional light. The wavelength spread is it is 0.001 nanometers. Try to imagine the spreading of laser beam. 0.001 nanometer, nothing but into 10 power minus 9 meters. Right. So it is clear that the laser radiation is highly monochromatic. And second thing is high degree of coherence. Already discussed coherence nothing but the property of wave being in phase with itself and also with another wave over a period of time and space or distance. So there are two types of coherence. One is the temporal coherence and spatial coherence. So temporal longitudinal coherence and transversal coherence. Both are we call as temporal and spatial nothing but longitudinal and transversal. For a laser radiation, our laser beam is having both the coherence, temporal and spatial coherence. Obeys the temporal and coherence. temporeal nothing but longitudinal wave. So the predictable correlation of amplitude and phase at one point on the wave train with respect to the another point in the same wave train is called as the temporal coherence. So in the same thing happened in different waves is called as the transversive coherence. The predictable correlation of amplitude and phase at one point with respect to the another point on the second wave. If it is happen in the same wave is called as the temporal. It will happen in the another wave is called as the spatial coherence. Try to observe the difference between the longitudinal coherence and transversive coherence, nothing but temporal and spatial coherences. So in the temporal coherence, we can measure or predict the amplitude and phase with respect to the another point in the same wave train. But here we are going to predict the amplitude and phase with respect to the another point of the another wave. So then our laser beam having both temporal and spatial coherence. That's why it highly monochromatic. If one thing is obeyed by the any radiation, it is called as a monochromatic in nature. But our laser radiation having both the temporal coherence and spatial coherence. That's why it highly monochromatic in nature. Coming to the directionality, the light ray coming ordinary light source travel in all directions. But the light emitted from the torch light, but the laser light spreads a few centimeter distance even it travels lakhs of kilometer distance. Okay, due to its high intensity only, directionality also very high. So we can measure the divergence using the formula arc by radius. So if you are taken in a wave in the light in the at a particular distance, if you taken from the starting point to particular. Wait, Amma. So if you have taken the laser light, so from the center, if you have taken laser light, it is not spreading much. So to find out the divergence of particular laser, we have taken the 2 points. So these are called D1 and this is a D2 distance. So arc radius also we can measure R1 and R2 using the formula arc by radius. So we are finding the divergence of laser beam. So that is about 10 power minus 3 radians usually. So since the divergence of light is very low, so we say that the laser light having high directionality. So the last one is the brightness. So see again the 4 characteristics of laser. First thing is high monochromaticity, and second thing is high directionality, high monochromaticity, high degree of coherence, high directionality, and high brightness. Try to remember the 4 characteristics of laser. Up to now, what we are discussing about the lasers. One is lasing actions. First one is mechanism of light emission. Here in the mechanism we have 3 mechanisms. One is absorption and second one is the emission. So in that emission we have 2 types of emission process, spontaneous and stimulated. Can any one of you tell me the difference between the spontaneous and stimulated emission of radiation? Please respond, Amma. Can any one of you please tell me the difference between spontaneous emission of radiation and stimulated emission of radiation? No one in the class? I am asking you, please tell me what is the difference between the spontaneous emission and what is the stimulated emission of radiation? Very good. Rule number 17.
Sir.
Yeah, 17.
Sir.
Ah.
చెప్పండి సార్.
ఏమడి అంట నేను క్వశ్చన్ నన్నే చెప్పానంట.
సార్
వాట్ ఆర్ ఆస్కింగ్ యూ? 57 less intensity and high intensity. Okay, so how can you define the stimulated emission of radiation and spontaneous emission of radiation? In that emission process that will happen, less intensity and intensities differ, but what is spontaneous and what is stimulated? One is occurred before completion of lifetime, one is occurred after completion of lifetime. I will tell you now already. So excited atom, this is an excited atom not permanently in the excited state. It stayed a particular time, that is called as lifetime. This is excited atom na? Excited atom not permanently stayed in the excited state. It stayed at a particular time called as a lifetime. The lifetime maximum average lifetime of every atom is 10 power minus 7 second. I already told you, already explained about that lifetime. So before completion of lifetime, if the atom is interacting with the matter, then some energy is absorbed by the atom and de-excited to the ground state with emitting of photon energy. That is called as stimulated. But after completion of lifetime, what we are going to observe? The atom automatically de-excited to the ground state energy level with emitting of photon energy. In both cases, energy is emitted by the atom, but it is having less intensity, so which we release in the stimulated emission process. The two photons are in phase. That is the difference between the spontaneous and stimulated emission of radiation. Both are emitted the radiation, but what is the difference? One is occurred before completion of lifetime, one is occurred after completion of lifetime. Here two photons are released in the stimulated emission process. Only one photon is released. Here two photons are released. Here only spontaneous emission, one photon energy. One photon is released here. In the stimulated emission process, two photons are released. What is the stimulated emission of radiation? Before completion of lifetime, this atom going to interact with the matter. Then from the matter, photon energy is absorbed by the atom and de-excited to the ground state energy level. That's why I clearly mentioned in the diagram, below the diagram, this is before stimulated emission and this one is the after stimulated emission. The two photons are released. These two photons in coherence. And these are differences between the stimulated emission and spontaneous emission. Coming to the characteristics, we have four characteristics again: monochromaticity, high degree of coherence, high directionality, high brightness. So our laser radiation having both temporal and spatial coherence. Try to remember about the temporal and spatial coherence. Temporal coherence means the predictable amplitude and phase with at one point with respect to another point in the same wave train. So here with respect to the another point in the second wave, same phase and amplitude. So high directionality, the spreading is very less. That's why we're having high directionality. So the radiation, the divergence when we are taken, the 10 power minus 3 radiations only when we are finding using the formula arc by radius. What is D1 and D2 and S1 and S2? D1 and D2 are the diameter of the laser spots at the distance of S1 and S2. This is the brightness, about the brightness. So after that we discussed about the population inversion also. So what is population? Usually in a system, the number of atoms present in the ground state is larger than or greater than the number of atoms N2 present in the higher energy state. The process of making N2 greater than N1 is called as the population inversion. Reverse. Usual occupation is N1 is always greater than the N2. If we achieved N2 greater than N1, called as the population inversion. Nothing but the number of atoms in the excited state is greater than the lower energy state is called as population inversion. To achieve the population inversion, we require pumping mechanisms. Various pumping mechanisms also we discussed, like optical pumping, electrical recharge, inelastic collision of atoms, chemical reaction, and direct conversion. So below in that slide, the two diagrams represents the normal population and population inversion. So metastable state. So what is the purpose of metastable state? So where the atoms are spending maximum time, that energy level we are taken as a metastable state, or we call as a metastable state. That metastable state purpose is to achieve the population inversion. That metastable state is playing an important role here. Means holding maximum time. Due to holding maximum time, the number of atoms is increases in that metastable state. So at the same time, using the pumping mechanism, we are sending atoms from ground state to the higher energy states. So for example, so initially we have more number of atoms in the ground state. More number of atoms ground state in the ground state than E2 and E3. For example, this is E1, this is E2 and E3. In the diagram, E2 state is the metastable state. So using the pumping mechanism, we are sending the atoms to the E3 energy state. So after that, what will happen? By the stimulated emission of radiation or spontaneous emission of radiation, the atoms are appear in the metastable state. What is the purpose of metastable state? That state holding atoms maximum time. That's why it stayed maximum time. Due to spending of maximum time, what will happen? Atoms are goes on increasing in the E2 state. At the same time, using the pumping mechanisms, atoms are goes on decreasing in the in the ground state. At a particular instant, what we are going to observe, the number of atoms in the E2 state is greater than the E1. Is called as population inversion. So using the metastable state and using the pumping mechanism, we achieve the population inversion here in between the E2 state to the E1 state. Means to achieve the population inversion, that metastable state and pumping mechanisms are necessary. So coming to the lasing action, here three steps involved in the lasing action. Before that, what are the requirements for the lasers? We discussed. What are the requirements for the laser? One is the active medium, where the lasing action takes place is called as the active medium. And energy source, to achieve the population inversion, we using energy source or pumping mechanisms. Optical cavity to give the optical feedback or up to sufficient intense. Photons are get multiple reflections between the two mirrors. Usually two mirrors or two polished ends of an active medium is called as resonator or used as a resonator. This is the lasing action. In the lasing action, three steps are involved. One is the pumping. What is the purpose of pumping again? The process of sending atoms from lower energy state to the higher energy state is called as pumping. Different pumping mechanisms are adapted depending on the type of laser. For ruby laser, optical pumping we are using. Like that, I have given examples also. Electrical recharge is used in the helium laser, direct conversion in the semiconductor laser, and CO2 laser, the mechanism of chemical reaction. Coming to the population inversion, so population inversion can be achieved with the presence of metastable state. Already we discussed about the metastable state. And stimulated emission of radiation. So what is stimulated emission of radiation? Before completion of lifetime, if the atoms in the excited state interacting with the matter, absorb the energy and de-excited to the ground state energy. In that process, two photons are released. So for example, see, this is the E1 state and E2 state. So we are sending atoms to the higher energy state. So by stimulated emission of radiation, so this atom is coming to the ground state energy level. So two photons are released. These two photons may be supplied to the two more atoms in the higher energy state and absorb this energy and de-excited to ground state energy level. So 1 is converting into the 2. Here 2 is converting into the 4. So 2 atoms are de-excited in a, so 2 atoms release 2 photons. So first one atom is de-excited to the ground state energy level either by stimulated or spontaneous emission of radiation. So if it is a stimulated emission, only 1 photon is released. That photon energy supplied to the one more atom in the excited state. Then stimulated emission of radiation is started between the energy levels. So here 2 photons may be supplied to the 2 atoms and absorbed by the 2 atoms and de-excited to the ground state energy level with emptying of 2 photons. Means first 1 is converting into the 2 and 2 is converting into the 4. Again these 4 photons, this 4 energy supplied to more 4 atoms in the excited state and absorbing that energy and de-excited to the ground state energy level. Means 4 is converting into 8. In the cascade process, the energy is or the photon energy is intense. So after sufficient intense, that is converting into the laser beam. So that is the lasing action. That is called as the stimulated emission of radiation. This one is. So even photon, H2 incident photon. So if a sufficient population inversion exists, then the stimulated emission can produce significant light amplification. So 1 is converting into the 2, 2 is converting into the 4, 4 is converting into 8, 8 is converting to 16. Like cascade process, the energy is intense. So that energy converting into the laser light finally. After sufficient intense, that photon energy converting into the laser beam and coming from the output mirror, which is partially reflected. Up to sufficient intense, these 2 photons. So here 2 ends. This total action takes place within the active medium. So these energy levels are presenting within the active medium. So these 2 mirrors, for example, this is a ruby crystal, this is a ruby rod. The 2 ends of the ruby crystal are silver. So up to sufficient intense, what will happen? These photons will get multiple reflections between the 2 mirrors. After sufficient intense, this partially reflected mirror, from the partially reflected mirror, we are getting the output laser. And this is a lasing action actually. So laser system consisting of active medium, active particles and energy source. So coming to the next topic, ruby laser. So about the ruby laser, we discussed in the next class. Up to lasing action and requirement for the laser and basic definitions involved in the lasers are clear to everyone. The topics are clear to everyone. Please respond. Only 63 responded. Please, by raising your hands, please respond. Only 2 students are there. 8, 10, 11, 12, 13, 14, 18, 22, 23, 25, 28, 30. Out of 55 students, 35 students are responded. Okay, no problem. So coming to the tomorrow session, so we have a laboratory session tomorrow. We don't have class, so all of you try to attend the lab session number.